So cooling and dehumidification. So here we are having a coil, and this coil is maintained at a temperature ADP, that is apparatus dew point, just a name given to it, apparatus dew point, or we can call it just TD4 if you want. And what we are going to do is we will be entering an air with at a dry bulb temperature TD1. Dry bulb temperature means just when we are measuring the temperature by using a thermometer, it will show dry bulb temperature. And after passing through this coil, we will be getting the new dry bulb temperature is TD2. This ADP means here, if the temperature of this one is very low, if the temperature of this coil is very low in such a way that the air, when it is passing through this coil, some of the moisture can get condensed. That means this ADP is less than dew point temperature, TDP1. TDP1 means dew point temperature is the temperature at which the moisture comes out as water droplets, and if the temperature of this apparatus is less than dew point temperature, definitely water will come out of this air. That means dehumidification takes place. So during dehumidification, here the temperature of this air decreases from TD1 to TD2. So first we will be having the relative humidity and dry bulb temperature of entering air. Let us take that it is something like 50. Relative humidity is 50 and TD1 is 35. So we are having this psychrometric chart, and here we are having the dry bulb temperature, and relative humidity is given in these green lines, and here look, it is the 50, relative humidity 50, and the dry bulb temperature is 35. So let's take that 35. So 35, 50. So now we can plot the point 35, 50 here. So I am representing it here like this is 35 and this is the 50 line. So let this be the first point. Then what happens is we are dehumidifying it. For dehumidification process to take place, first let's check whether the given coil temperature, let us take that as, so it is 35 and 50, let us take that as 15. So let the given dew point temperature be 15. That given apparatus dew point temperature, that temperature should be less than dew point temperature of air. So here 35-50 point is this one. If we are drawing the horizontal line, we are able to get the dew point temperature, and that is about 23, 24, etc. That is definitely greater than dew point temperature, definitely greater than apparent dew point temperature, because it is given as 15 in the question. So that means dehumidification process will take place. So we are quite clear that if TD1 of 35 and relative humidity 50% is passed through the coil of 15 degrees Celsius, dehumidification process will take place. Now we want to find TD2. For that, an equation is available. Look, of the air passing through this conduit, a part of it will be passing through this coil and remaining will be bypassing it, and that bypass factor can be found out by, that is equal to TD2 minus ADP by TD1 minus ADP, and here bypass factor will be given. So from bypass factor, let us take that is 0.15 or so. If we are taking bypass factor as 0.15, then TD2 minus ADP, it is given as 15 in the question, TD1 is given as 35 and it is 15. From that TD2 can be found out. So we are able to obtain TDT now. So now we have dry bulb temperature, TD2, etc. So next thing is we should plot this one, TD2. For that, in question ADP is given, so that ADP should be marked here, and this TD2 will be definitely in between these 2 points. So what we want to do is we will be drawing a straight line, and from this we can find the TD2. Let us we will get it as 0.15 into 20 plus 15. So that is about 18 degree. TD2 is 18 degree. So here we can plot 18 degree, and that will come in between. So now we are able to obtain TD2. So from this TD2, now this is the actual process, actual dehumidification process. Now if you are looking in another way, this can be resolved into two parts, like this one. This is the one part, this is the second. Here the temperature remains constant. That means we can call this as latent heat addition, just for changing that particular vapor to liquid, latent heat liberation. And this is sensible heat liberation, SH. So we are able to obtain LH and SH difference in a different manner, because here we will be having an enthalpy line, and if we are drawing perpendiculars, we will get to 2 points. Let us take this is 1, this is 2, this is 3. So H1 minus H2, that will be the latent heat. H2 minus H3 will be the sensible heat. So we can find the sensible heat factor. That sensible heat factor is equal to H2 minus H3 by H1 minus H3. So this is how we analyze dehumidification and cooling process by using a psychrometric chart. Thank you.